topic of a BSc fourth paper of the fourth sem of Davangere University. By the way, I am Dada Pires from Government Degree College, Chenigiri. This is the topic come under the polarization, and the subtopic is the axial crystal. Let's we discuss about the axial crystal. Usually, as we see in double refraction, there is the optic axis is there through which the velocity of extraordinary and ordinary ray remains constant there. So on this axis we divides the crystals into two types. One is uniaxial crystals and another one is biaxial crystals. As its name says, uni means mono, only one. So biaxial means is a two axis. So these are so what is the uniaxial crystals? As its name says, the crystals which have a single axis. So this is called the uniaxial crystal, the crystal which obey the only one axis, optic axis, through which the ordinary and extraordinary velocity will be same in one direction. What are the which are the uniaxial crystal? Like quartz. As you see, this is the quartz we can get for the uniaxial. It can shape into a crystal. Perfect. It is a rough crystal. And the calcite, another example for the uniaxial crystal. This is the calcite crystal, and this is the tourmaline crystal. This is also a uniaxial crystal. And fourth one, as usual, ice. You are see the ice black. So these are the four are the example for uniaxial crystals. So as this name says, biaxial means the crystal which have two axes. Two optic axis, such crystals are called biaxial crystals, through which the two rays, ordinary ray and extraordinary ray, have the same velocity. Such crystals are called biaxial crystals. Example for the biaxial crystals are borax. This is the borax crystal. It's a roughly one. When it is polished and make it to be a perfect angle, that gives to a crystals of a perfect shape. And this is the mica. This is about the mica of a biaxial crystal. Topaz. You see this type of a precious stone, topaz. And the selenite. And this is the selenite crystals of a rough one. They are not polished one. And these are called the biaxial crystals. Depend upon the velocities of the ordinary and extraordinary. They are again two types. One is negative crystals. Example for this negative crystal is calcite. And positive crystal, this is the negative crystal, calcites, crystals of calcites. And these are the positive crystals and quartz, but both are uniaxial crystals, but their velocity is different in different way. And this calcite and quartz, negative and positive crystals. So in positive crystals, like example is quartz. What's happen when the velocity of extraordinary and ordinary? Let me see. In this picture, we see the extraordinary rays lies inside a sphere of ordinary ray. So here is the extraordinary ray travels very slowly. than the ordinary ray. Hence, it is becomes and minimum to perpendicular to the directions of. So here the extraordinary have minimum velocity in a direction perpendicular to the optic axis. So take the perpendicular to this optic axis. So it's have a perpendicular like this way, perpendicular to this axis. It's a very minimum velocity it have. So it is an, that's why it is an ellipsoid shape. It follows the ellipsoid shape and encloses inside the sphere of ordinary ray. And seeing here, the extraordinary and ordinary rays are meeting at a optic axis at the top and bottom. Means they have same velocity along this optic axis. That's why they are meeting at a in a external points. So in this case, the diameter of the ordinary ray is equal to the major axis. This optic axis is the major axis of a extraordinary ray, and this is equal to major axis equal to diameter of the sphere also, and it is maximum perpendicular to the directions of the optic axis and equal to the velocity of ray along the optic axis, and have minimum value the perpendicular to the direction perpendicular to the optic axis, but refractive index of the extraordinary is less than the refractive index of the ordinary. Thus the sphere is thus enclosed inside the ellipse. So its value is of ordinary is less than that one in the negative crystals. So diameter of the sphere, this is the diameter of the sphere AB, and is equal to the minor axis of the very small distance, that is minor axis of the ellipsoid of a extraordinary ray. So let me compare this positive and negative crystals. Example for positive crystal is quartz, whereas for the negative crystal is calcite. So in positive crystal, the extraordinary ray travels very slowly than the ordinary ray, where this extraordinary ray travels faster in the ordinary rays. So whereas comparing further, in positive, the ordinary wave surface lies outside the extraordinary waves, whereas in negative, ordinary wave surface lies inside the extraordinary wave surface. Whereas in positive crystal, the velocity of R is constant in all directions. Velocity of ordinary ray is constant, whereas the velocity of ordinary ray is constant in all directions also, because they follow the sphere. Hence, in positive crystal, it is maximum and equal to the velocity of ordinary along the optic axis, and it is minimum and equal to the velocity of along optic axis through ಹೋದ್ರೆ ಎರಡು ಈಕ್ವಲ್ ಆಗಿರ್ತವೆ. ಬಟ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಇದ್ರೆ ಇದು ಮ್ಯಾಕ್ಸಿಮಮ್ ಆಗಿರುವಂತದ್ದು, ಇದು ಮಿನಿಮಮ್ ಆಗಿರುವಂತದನ್ನ ಕಾಣ್ತೀವಿ. ಇಟ್ ಹ್ಯಾಸ್ ಮಿನಿಮಮ್ ವ್ಯಾಲ್ಯೂ ಇನ್ ಎ ಡೈರೆಕ್ಷನ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಟು ದಿ ಆಪ್ಟಿಕ್ಸ್, ಆದ್ರೆ ಇದು ಮ್ಯಾಕ್ಸಿಮಮ್ ಆದಂತಹ ಡೈರೆಕ್ಷನ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಟು ದಿ ಆಪ್ಟಿಕ್ ಆಕ್ಸಿಸ್ ಇರುವಂತದನ್ನ ಕಾಣ್ತೀವಿ. ಸೊ ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ ಇಸ್ ಆಫ್ ಎಕ್ಸ್ಟ್ರಾರ್ಡಿನರಿ is greater than in refractive index of ordinary ray in a positive crystal, whereas in negative crystal, ordinary refractive index of mo is ordinary rate is greater. That's why these are the differences, positive and negative crystals. So as we see from this way, what is axial crystals, what are its main types about the axis, and what is the another types of crystals, the behavioring and ordinary and extraordinary rays. There are two types, negative and positive crystal, and comparing with these two one, we distinguish between the positive and negative crystals. These are about the axial crystal. Okay, thank you very much.